Okay, so we didn't quite get through everything in 4.1 and 4.2, so I just want to make sure everything's covered. So in class, we talked about we started with the example with drilling depth and how long it takes to drill through 5 feet of rock. Um, we talked about the relationship between the input variable, the explanatory variable, the x value, and the output slash y slash response. Okay? So the initial topic would just be to see what they look like in a scatter plot, right? Without getting into the math. And you say, oh, there's a relationship there. There's a correlation. As x increases, y increases. Okay, and it's kind of linear, right? And it's also positive. As x goes up, y goes up. Positive linear, or how we're describing that. Here's the strength of your relationships. The straighter the line, the stronger the relationship. All right. And we talked about something that measures that. Um, so moving on, and that's the correlation coefficient. We don't have to worry about that formula. StatCrunch will do it for us, but we have to be able to interpret. Okay, so these two slides are important. It'll always be between -1 and 1. The closer it is to +1, the better the relationship is. And the closer it is to -1, the better the relationship is, right? It doesn't matter if it's positive or negative when you're speaking in terms of strength of correlation, okay? Oh, what else do we have here? It's not resistant. We talked a little bit about that. A couple outliers, dots that are not close to the other dots, would really affect R. Some examples of R, and from here we're going to talk about the line that goes through all of these, right? The least squares regression line. Okay, so for this example, the correlation coefficient, if we calculate, which I showed you how to do in StatCrunch, using regression simple linear, then you should get this value. Okay, StatCrunch will give you that. Correlation coefficient R. So the question is, how good is 0.773? This is what I did not get to in class. How good is 7.773? Well, just looking at the scatter plot, we saw there was a relationship, but how good is it? Well, this number tells us that, okay? And it depends on n. So it's not just as simple as saying, as long as it's greater than 0.55, then we'll call it a linear relationship. It doesn't work like that. It depends on the number of values in your data set. Okay, so the relationship here is if you have a small data set, you need R to be really close to 1. And this works with, you take the absolute value. This works if any of these are negative, same thing. You can think of it as taking the absolute value and then just saying, well, how strong is it? Okay. So you'll notice then, as long as you have a decent size sample, right, here, if you just get the 14, then you only need to be over 0.532. All right, these are called critical values. It's like a threshold. You say, all right, if my data set is 12, which it is, right, for the drilling example, as long as R is bigger than this number, then we have a linear relationship. And in our case, it's positive. Okay, so you have to do some of those on your homework. You'll either calculate R yourself or it'll be given to you. Say, here's R. Do we have a linear relationship? It depends. Depends on n. Right? In this case, yes, we have a linear relationship because the critical number for n being 12 is 0.576, which isn't really that close to 1, right? So the threshold here isn't as high as you might think it would be. So it's still positive and linear. And that makes sense to us, right? If you go back to the scatter plot, here's the scatter plot. So this right here goes with an R value, correlation coefficient value of 0.776. You can't really predict that from just looking at the scatter plot, but it should make sense once you see it. You say, okay, it's a linear relationship, it's moderate, but you can see the correlation. As x increases, in the most part, y is increasing. Okay, so I hope that makes sense for the critical value. Like I said, it's not just easy as just taking a look at R and saying, oh, that's close enough to 1, we're good. Right? You have to look up the value in these charts. And when you do your homework, the chart will be given. Okay, so a typical homework question for this will be, here's some data, you open in StatCrunch, you go to regression, simple linear, and it gives you all your values. And then one of those values will be the correlation coefficient. And then you'll have to determine if it's linear, and this chart will be provided. So you just have to compare this value to these values and considering your sample size. Here's something I didn't talk about. We have a relationship. Here's a relationship between ice cream and crime rates. This is like a famous statistic example. As ice cream sales increase, crime rates increase. Okay, they're correlated. By our definition, they're correlated. If I have ice cream down here, and ice cream sales, so in dollars, some measure of that, and then crime rate, however that's measured, number of violent crimes, I don't know. It's just crime rate. If there's a lot of crime, the rate's high, okay? So don't worry too much about the unit because I'm not really sure what that would be. The point is, as ice cream sales go up, right, for data, how much in a city, I used to live in Baltimore, they would sell a lot of ice cream, or a lot of the ices were real popular there. And this was true in Baltimore, especially true in Baltimore. As those went up, as people were making a lot of money selling ice cream or ices, crime rate went up, right? So you would have a positive, really strong, positive linear correlation. But they're not really connected in any way, right? What's the lurking variable here? The lurking variable is temperature, right? When the weather gets nice, people start buying ice cream shops open. And when the weather gets nice, so does the crime rate goes up, right? More people are outside later at night, and those are a pretty strong correlation. But there's a lurking variable, right? And that would be temperature or the season, summertime. So we have to be careful. There's a lot of things that are correlated that aren't really related, other than that they both are trending in the same direction. Okay. So now we got to do a little bit of algebra. I got to do a quick algebra review. Let's see. If I want to, so the point is, I want to show you how we're getting a way to get these least squares regression lines. So here's your data, and there's two ways to get a line. One, you can figure it out yourself. Two, you can just run it through StatCrunch, and it'll spit out your least squares regression line. So we want to I want you to do it a few times on the homework so you at least get the idea of what we're doing here. So this is actually not the best way, because what you do is you would just have to pick 2 points, and you're hoping it's most representative. So I'm going to pick these 2 points and find the equation of a line. So we got to do a quick algebra review. M equals, remember, y2 minus y1, 2.2 minus 5.7. And then the x's that go with that, x2 minus x1, 6 minus 4. If you plug that into your calculator, just be careful. Compute the numerator, compute the denominator, that should be 2. And then it should spit out the following number, negative 0.95. That's the slope. You got to be able to interpret that slope. In this case, there's no units given, so it's just x and y for practice. And then what do you do next? Well, you can do it this way. To find the equation of the line, y equals mx plus b. That's the goal here. I'll show you the stat version of this in a minute. This is the algebra version, y equals mx plus b. So how do you do that? This is the point slope formula. So you take one y value, doesn't matter which one, you pick a point, either of these 2 points, since those are the ones we use for the slope, and you plug it into this formula. And in any formula on a test, I'll give you. So if you don't remember your point slope formula, I'd give you that. And what do? You plug in m, you plug in one particular point, which is represented by x1, y1. So m is 0.95, negative 0.95. And the point I'm choosing is this guy. Plug the x value here and the y value right there. Okay. And then you work it out. You run, remember your algebra, you distribute the negative 0.95. You get this, and then you're going to add 0.57, and there's your y-intercept. right? That's B. B is the point 0, comma B is your y-intercept. Okay, so I hope that makes sense. If you need another example, just go to YouTube and say, find the equation of a line with 2 points, and you'll see a bunch of examples. You'll have to do a few of those for homework. And here's what we just did. We found a regression line. We picked, I think it was this point and then this point. And you'll notice I could have picked 2 other points and you would have got a slightly different line. And the problem with this method is, well, it's probably not the least squares regression line. It's just an estimate of it. Okay. And then from that, what we typically do once we have the equation of the line, whether we get it by hand or we get it from StatCrunch, we can answer questions. All right. What's y if x is 3? Plug in 3, it spits out y, right? Which should be somewhere around it's on the line. This value is on the line, but it should be close to any data value that was input 3. Okay, so we can look at the difference real quick. Let me jump back. Data 3, 5.2, data 3, 5.2. That's this little dot right there. Predicted value from our model 3, 4.75, right? Those most likely aren't going to be the same thing because the least squares regression line is, or the line you're modeling your data with isn't going to hit all your points. It's going to kind of go through them. Okay, so what we have then is that difference. We have a what's called a residual. It's the observed value, the data value, minus the predicted value. It's how far off you are. You can think of it as an error, right? So the observed value we saw was 5.2. That's the y value, right? For x equals 3, we have like 2 y values. The actual value and the predicted value from our model. And what the residual is the difference of the two. Okay, that's how far off you are. So the way the least squares regression is it's going to minimize all of those added together. So again, we have, sometimes they'll be negative if they're below. If you have a data value here and you do the residual using this little formula, you get a negative residual. So you'd have to square them like we did with the standard deviation and add them all together. So that's where you get the term least squares regression. If you square all your residuals, add them all together, you have to have that smallest sum possible is going to give you your best line. Okay, that's the idea behind it. And here is what y equals mx plus b looks like when you do it in stats class. Okay, y hat is a predictive value. We use hat for predictive values. And then b1 you can consider m. B naught you can consider the y-intercept. Okay, so if you ever have to find, so the goal is to find this line. You can do that one of 2 ways: by hand, like I just showed you, which isn't the best way, or using StatCrunch, which is the best way. All right, and I won't make you do this. That's the value of the slope using standard deviations of both the y data set and the x data set. And you can see the connection here with r. Right, if r is negative, the slope's negative. If r is positive, slope's positive. And here is your value. Here's how we can compute b naught, which is the y-intercept. Okay, but again, we won't use this method. We'll either use the basic method from algebra class, or we'll use mostly the computer, and that's how we'll get this. Okay, we don't have to worry about these equations. All right, we'll just have to interpret. That's the importance here. I want you to be able to interpret slope, interpret y-intercept, and then use it to predict values. Okay, so let's see. We talked about x bar, y bar, back to my data. Okay, so I just want to finish this video by answering these 4 questions. Find the least squares regression line, StatCrunch, and then answer some questions. Okay, so StatCrunch will knock out the least squares regression line. There it is. Remember, if you hover, or you can just go over to see the equation of the line. I'm going to run out of time. My max video time is 15 minutes. So I'm going to go ahead and stop it. The second video should only be like 3 minutes long.